Well, hello everyone and welcome to an unexpected second part about the latest video I did. You see, the last video we talked about the flat earth and misunderstanding the application of the inverse square law. And I was going on and on, and I even left a comment about that he didn't take the angle into account, and I thought I'd explain what I mean by that, right? So imagine that you have two torches, right? One right here and the second one here. And the first torch, they are supposed to be at equal height. I'm bad at drawing, you know that by now. And the first torch is just shining its light straight down, right? And you have the light of the torch distributed over an area 1. And you do the same thing, and now you hold the torch at an angle, and of course, as you know, the area now gets bigger. But so area 1 is smaller than area 2. However, the power of the torch is a constant. So, thus, area 1 has more watts per square meter than area 2. So you can see that even though they are of the same distance to the ground, they have a different, and that's important, they have a different amount of energy, of power per square meter, or also of energy per square meter, right? Energy is just, power is just energy or work over time, so, you know. Yeah, so I thought I'd explain it, and I thought you see, I programmed how it would look like on the two different models, just to show everyone that it's very much possible on a globe Earth. Oh, of course it is, you know. So, yeah, I'm gonna show you that. So, what I did here is that I just coded something. I originally intended to screen share it from my work computer, because I did it on my work computer. But for whatever reason, when I screen share and capture the screen share, I can't type anything on my work computer from remote, which is interesting. But, you know, please pardon my code. I'm a scientist in training. I don't care much about beautiful coding, and you can see that very often, I believe, but it's functional, and that's all that counts, really. So what I did is I'm going to freshly run this here. What I did is I made some predictions, really, right? The thing that I want to show here is that of course it works on a globe Earth, and what some of the problems are with flat Earth here. So first of all, the only important parameter here really is the height of the sun that is moving overhead. You can see that the with angles and without angles is a bit there is quite a discrepancy. Like the general shape is the same, but the actual values are different. This is normalized, so there is no cause for alarm there. And yeah, so because that's the first thing that they did in their video, is showing the sun go overhead, or like a light source going overhead. And while that was in principle fine, they did it without the angles. So the red curve and the blue curve is really what they should be looking at when they look at watts per square meter, right? And now for the flat Earth. Now this took me a bit more time than I'm proud to admit, but really what's going on here is that I have a location on the equator for simplicity, and the sun is moving in flat Earth style in circles, like around the tropic of wherever it is right now. I am moving it over the equator. And now the things are important, because I use the actual lengths of stuff, right? I use the length of the equator, which is length of the equator here, which I you know, that's in meters, of course. And the height of the sun is also important. Now, flat earthers usually are about saying that it's a few thousand kilometers at best, right? So I went with 3,000 kilometers just to have a little look-see. And when you do that, oh boy, this is what the normalized radiation at the equator would look like if the sun would move overhead. So right at noon, you would receive an incredible amount of light, and within like 1 hour, 2 hours, it would dark down. And that's of course not what we see. So I adapted it to 3 times 10 to the 7 meters, which is 30,000 kilometers, which is way higher than I've heard any flat earther claim so far. But then it looks somewhat realistic, although the sun doesn't set, unsurprisingly, because the sun couldn't set on a flat Earth. Now I already hear the flat earthers in the chat. Well, if anyone is actually writing comments, I can already hear the protest about, well, you know, the atmosphere, it magnifies it, and so the sun could set. And, well, could you show me how, please? That would be nice. Other than that, if you were to, because they have a magic sun with lampshades, if you were to cut it off at 6 and at 12 hours, this is the light curve you'd get, which is a bit strange because it starts at 0.4 times the maximum radiation that you get. But, you know, in all fairness, I did not take the atmosphere into account in any model, so I guess that's what they would invoke now, is that their atmosphere magically fixes things. And if I look at the globe Earth, you know, because the globe Earth was actually surprisingly simple to program, because it's just a surface that's revolving. That was really easy. It's just a cosine, and then you get this curve here, right? Which of course makes sense because the sun can set even purely geometrically without any kind of atmosphere. The sun sets. The only thing that I could possibly complain about here, like from what we see, is that the drop off here is rather steep. As far as I know, the atmosphere actually would make this somewhat less steep, but and in the end there would be funny stuff going on, because, you know, when the sun's right over the horizon, the passes through a lot of air, so things look a bit differently there, right? But apart from that, that is what it would look on a globe Earth. And if you remember, I would refer to my last video, the ones where I said that the flat earther and the inverse square line things. If you look at the curve that they showed there from Denmark, if you cut this one off here at the 6 and 12 hour marks, although there wouldn't be a good reason to do so, but if you cut them off and if you use this one, the best I can do for flat Earth here is say it's inconclusive. It works on both models sufficiently enough. That's the only thing I can say. Again, without taking the atmosphere into account. I'm not an atmospheric scientist. So yeah. So I thought I'd just drop a little video about my programming efforts.